Midea Commercial Air Conditioner VRF Repair Guidelines. This video is only used to introduce the troubleshooting and repair process of Midea CAC V4 Plus VRF products. During the actual repair process, please consider the actual installation may differ according to different locations. This video contains 4 parts. Part 1. V4 plus VRF System Refrigerant Circulation Introduction. Part 2. Analyzing and troubleshooting the electronic function of the outdoor unit. Part 3. Analyzing and troubleshooting the electric function of the indoor unit. Part 4. Analyzing and troubleshooting the malfunction of the refrigerant system. Part 1. V4 Plus VRF System Refrigerant Circulation Introduction. 1. Cooling Circulation Introduction. After compression, the high pressure and temperature gaseous refrigerant is discharged from the compressor, then enters into the oil separator. Refrigerant in oil is divided by the oil separator, and the oil returns to the compressor via the oil return capillary pipe, which is connected at the bottom of the oil separator. At the same time, the surplus oil will be balanced to the other combined compressors by the oil balancing pipe. So we position the oil return orifice and oil balance orifice at the different levels at the separator bottom. The refrigerant is discharged from the top of the oil separator, then enters the 4-way valve. In cooling mode, the 4-way valve is in power-off condition. The refrigerant goes through the 4-way valve and enters the outdoor condenser. In the condenser, the gaseous refrigerant changes to gas-liquid state by condensation, and from high temperature and pressure reduces to medium pressure and temperature. After condensation, the refrigerant reaches the outdoor electronic expansion valve. The electronic expansion valve adjusts the size of opening in order to control the refrigerant flow volume according to the discharged gas temperature and pressure of the compressor. After passing through the outdoor electronic expansion valve, the refrigerant enters the high-pressure accumulator. Due to gravity, the liquid-state refrigerant will be separated at the lower part, and gaseous refrigerant will be at the upper part. As the discharge pipe is placed at the bottom of the accumulator, it guarantees that the discharged refrigerant is in the liquid state. So, during maintenance, it should be clear which is the outlet pipe, which is the inlet pipe, to make sure that in cooling mode the refrigerant passes to the indoor side as in a liquid state. The refrigerant passes through the high-pressure accumulator and enters the connection liquid pipe between indoor unit and outdoor unit, then reaches the indoor side. Before entering the indoor evaporator, the refrigerant has to go through the indoor unit electronic expansion valve for throttle and pressure reduction. The size of the opening is adjusted according to the temperature measured by T2B sensor at the air outlet of indoor unit evaporator. The medium temperature and pressure liquid refrigerant becomes a gas liquid refrigerant with low temperature and pressure by throttle. After throttling, the gas liquid refrigerant enters the indoor unit evaporator, then absorbs heat and evaporates. When the refrigerant reaches the outlet, it should be in a gaseous state, ensuring the refrigerant can fully evaporate with the best cooling performance. The refrigerant passes through the indoor unit evaporator and enters the connection gas pipe, then returns to the outdoor side. Gaseous refrigerant passes through the 4-way valve of the outdoor unit and returns to the low-pressure accumulator. At this time, the liquid refrigerant, which is partially evaporated, or the surplus refrigerant, due to low load operation, will be deposited at the bottom of the accumulator, while the gaseous refrigerant remains at the top. The location of the low-pressure accumulator discharge pipe is set at the top, which is in an opposite position compared to the high-pressure accumulator. This ensures the refrigerant absorbed by each compressor is in its gaseous state. Except for storage of the surplus liquid refrigerant, the low-pressure accumulator also stores lubricant oil, which is used in the circulation operation of the system. An orifice is positioned at the bottom of the accumulator to ensure oil returns to the compressors through capillary action in time. Gaseous refrigerant passes through the low-pressure accumulator and is absorbed by the compressor. Thus, a cooling circulation process is completed. During cooling operation, some solenoid valves are intentionally equipped to make sure the system operates under the optimum state. SV6. During the cooling operation, if discharged gas reaches 90 degrees Celsius or the pressure is higher than 3.5 megapascal, the SV6, which is in parallel with the outdoor EXV, will be powered on and opened to increase the refrigerant flow so that it can ensure efficient operation of the system. SV2. During the cooling or heating operation, if the compressor discharge temperature reaches 105 degrees Celsius, the SV2 connected with the outlet pipe of the high-pressure accumulator will be powered on. The low-temperature and pressure liquid refrigerant is formed through the capillary pipe and then injected into the main suction pipe to absorb heat and increase evaporation, which can cool down the compressor by reducing the suction temperature. SV4. During the cooling or heating operation, after the master unit has been operating for 20 minutes, the SV4 in the master unit will be open for 3 minutes. After 5 seconds, the SV4 valve in the slave unit 1 will be open for 3 minutes, and after another 5 seconds, the SV4 in the slave unit 2 will be open for 3 minutes, and the process repeats. This cycle repeats every 20 minutes. However, the SV4s in a powered-off slave unit remained closed. When the system is powered on or shut down, the SV4s also open 2 minutes to ensure that the compressor won't operate with insufficient oil during long-term running. SV1. During the cooling or heating operation, the corresponding SV1 will be open, and it will be closed when the unit stops. This function increases refrigerant flow and prevents any refrigerant from entering an outdoor unit in standby mode. Two, heating circulation introduction. After compression, the high-pressure or temperature gaseous refrigerant is discharged from the compressor, then enters into the oil separator. Refrigerant in oil is divided by the oil separator. Then, the oil returns to the compressor by the oil return capillary pipe, which is connected at the bottom of the oil separator. At the same time, the surplus oil will be balanced to the other combined compressors by the oil balancing pipe. So we position the oil return orifice and oil balance orifice at different level at the bottom of the oil separator. The refrigerant is discharged from the top of the oil separator, then enters the four-way valve. In heating mode, the four-way valve is power on. After passing through the four-way valve, the refrigerant enters the indoor side by the connecting gas pipe. The condensation function of the indoor unit converts the high-temperature and high-pressure gaseous refrigerant into gas-liquid refrigerant at medium temperature and medium pressure. After condensation, the refrigerant reaches the indoor electronic expansion valve. The size of the valve opening is adjusted according to the temperature of the T2 sensor in the indoor unit, ensuring better heating performance by regulating the refrigerant flow. After passing through the indoor electronic expansion valve, the refrigerant enters the connecting liquid pipe, returns to the outdoor side, and enters the high-pressure accumulator in the outdoor unit. After the refrigerant passes from the high-pressure accumulator, it goes through the electronic expansion valve of the outdoor unit. The size of the opening is adjusted according to the temperature and pressure of discharged gas. The liquid refrigerant of medium temperature and medium pressure changes into gas-liquid refrigerant with low temperature and low pressure by throttling. Gas-liquid refrigerant enters the outdoor condenser and absorbs heat in the condenser. When the refrigerant reaches the outlet, it should be in a gaseous state, ensuring the refrigerant can fully evaporate with the best cooling performance. Gaseous refrigerant passes through the four-way valve of the outdoor unit and returns to the low-pressure accumulator. At this time, the liquid refrigerant, which is partially evaporated, or the surplus refrigerant, due to low load operation, will be deposited at the bottom of the accumulator while the gaseous refrigerant remains at the top. The location of the low-pressure accumulator discharge pipe is set at the top, which is in an opposite position compared to the high-pressure accumulator. This ensures that the refrigerant absorbed by each compressor is in the gaseous state. Except for storage of the surplus liquid refrigerant, the low-pressure accumulator also stores lubricant oil, which is used in the circulation operation of the system. An orifice is positioned at the bottom of the accumulator to ensure oil returns to the compressor through capillary action in time. Gaseous refrigerant passes through the low-pressure accumulator and is absorbed by the compressor. Thus, a heating circulation process is completed. During heating operation, the defrosting solenoid valve SV5 is intentionally equipped to make sure the system operates under the optimum state. SV5. During the heating operation, if the outdoor unit reaches defrosting condition, the four-way valve will be powered off. The system changes into cooling mode. At this time, the SV5, which is connected at the high-pressure accumulator outlet, will be powered on. Some refrigerant passes through the SV5 valve and enters into the low-pressure accumulator quickly. Thus, increase the refrigerant circulating speed to realize quick defrosting. Part 2. Analyzing and troubleshooting the electronic function of the outdoor unit. This section introduces the repair methods of VRF, V4+ outdoor unit functions. It includes 15 parts. E0. Malfunction of transmission between outdoor units. E1. Reverse phase/open phase. E2. Malfunction of transmission between indoor units and outdoor units. H7. Improper indoor units quantity. E4. Malfunction of temperature sensor for outdoor air/condenser outlet. E9. Malfunction of power supply. H0, H1. Malfunction of transmission among the chips. H2, H3. Improper outdoor unit quantities. H8. Malfunction of high pressure sensor. P0. Top cover of compressor overheat protection. P4. Discharge gas high temperature protection. P1. Actuation of high pressure switch. P2. Actuation of low pressure switch. P5. Condenser outlet high temperature protection. P6. Module protection. P3. Compressor over current protection. P9. Outdoor fan module protection. E0. Malfunction of transmission between outdoor units. Only slave unit displays. When several outdoor units are in parallel connection, they need to be connected by the communication cable from the outdoor unit H1, H2, E-port, and address master unit 0, first slave unit 1, etc. When slave units display the E0 malfunction code, the reasons would be as follows. Cause of E0 malfunction. Communication cable is broken. Master unit is powered off. Master unit PC board malfunction. Slave unit PC board malfunction. Wires are not correctly configured as per instructions. Failure to use 3 core shielding cable. Repair instructions when E0 appears. Step 1. Check to ensure the outdoor unit's address set. Master unit address should be set as 0. 1 for slave unit, 1. 2 for slave unit, 2. 3 for slave unit, 3. And it is invalid when the address is more than 3. If the setting has errors, power off the outdoor units and reset the address. If it is correct, proceed to next step. Step 2. Check the communication cable. All the H1, H2, E port of the outdoor units must be connected by the shielded cable, and the wires should not be reversed. H1 port of the master unit is connected with slave unit's H1, and H2 port is connected with H2 port. Use of the OHM range of multimeter to check the resistance between PQE of communication cable if it is in short circuit or open circuit. If short circuit happens, reconnect the outdoor unit communication cable. After the above repair, if malfunction still exists, the PC board of outdoor unit should be broken. You have to replace a new one. E1. Reverse phase / open phase. Input terminals of the compressor are U, V, W. Corresponding power is A, B, C. Please make sure that the compressor can run normally and avoid the damage by reversal operation. When outdoor unit appears E1, normally it needs to change either phase of the power cable. After that, if problem still exists, it should be the reason of power supply, normally because of lacking power phase. Phase sequence checking is conducted only at the first power on. If wrong phase malfunction happens, it will disappear until the phase sequence is correct. Repair instructions when E1 appears. Step 1. Cut off the main power supply of the system. Change either phase of the power cable for the outdoor unit with malfunction. Then power on the system and check if problem still exists. If so, please go to next step. Use AC voltage range of multimeter to check if the power supply lacks phase. The power cable connection is loosened or not. If phase is lacked or unbalanced, you should check the power source to find the reason. After the above repair, if malfunction still exists, the PC board of outdoor unit should be broken. You have to replace a new one. E2, H7 malfunction of transmission between indoor units and outdoor units. E2 malfunction of transmission between indoor units and outdoor units. H7 improper indoor units quantities. Appearances. Timer lamp flashes quickly. Indoor units quantity display from outdoor mainboard is unstable or decreasing. Poor cooling or heating performance of some indoor units. Causes of communication malfunction. 1. Address duplication of indoor units. 2. Address setting switch is not in the precise position. 3. Set the network address by mistake. 4. Signal wires are star connection. 5. Failure to use 3-core shielding cable. 6. Signal wires are too long. 7. Interference. 8. PQE is short circuit. Repair instructions when E2H7 appears. Step 1. Use the OHM range of multimeter to check the resistance between PQE of communication cable if it is in short